Welcome back. We are returning to technical talks with a talk on AWS config rules and remediation. Before we get started, once again, I would like to thank our sponsors, especially Bridgecrew. Bridgecrew by Prisma Cloud is the cloud security platform for developers. Built on open source, it finds and fixes infrastructure as code misconfigurations, enforces policies from code to cloud, it integrates throughout the development lifecycle. Try it out for free. We will take questions in the room, as well as on Slack, as well as on Twitter, as we have done. Looking forward to it. Please welcome Scott and Adam.
Hey, everyone. I'm Scott Pack. This is Adam Chou. Welcome to our session on AWS config rules and auto remediation. We are cloud security architects at Adobe. About 2 years ago, we started migrating our previous cloud security posture management program, which was purely working in a detective mode, and moved it into an enforcement and remediation mode. We're now running this program across about 1,500 AWS accounts, doing assessments over hundreds of thousands, probably millions of resources per day, triggering hundreds of remediation actions per month. I'm not going to try and sell you on config rules. In fact, by the end of it, maybe you'll decide that you want to look at other options, but it's been effective for us, and we're going to try and give you some of the idea of what that process was for us, what some of the building blocks were, and how it works. So if you're running in the AWS compliance and governance realm, as I imagine most people in this room and dialed in are, you already have some starting point of what your policy should be, some sort of patterns, anti-patterns, don't do this thing instead. When you're looking for compliance tools to make sure that those policies are being adhered to in your AWS environments, you're probably looking at one of two control families. You're looking at IAM, specifically SCP, which expresses those policies in IAM language, or you're looking at AWS config, which is capable of capturing the resource definitions in your account and then assessing those resources against whatever rules that you may want to express in code. That's a core difference between these two services. SCP is expressed in IAM, config rules are expressed in code. Core to the config service is the configuration item and the configuration recorder. When you enable a config service in your account, it creates a resource called the configuration recorder, which is informed whenever one of the other resource providers, EC2 or SQS or S3 or whatever, creates a resource. Config creates a representation of that resource called a configuration item. It's a JSON object, contains a lot of the same properties, fields, everything that you would see when you make a describe call against that same resource. You can set up periodic delivery of all the resources inside of config as part of a snapshot to an S3 bucket. You can set it up to stream deltas to an SNS topic, or you can query it through their APIs. You can also set those CIs to be routed to a config rule. So let's talk about some of the building blocks that are used for config rules and remediation. So as many of you do, we've got kind of a master security account, and then all of these other member accounts where the production workloads, dev, stage, R&D, everything, the customer-facing stuff lives. Some of the infrastructure is deployed into the security master account. Other pieces are deployed into the member accounts. In the member accounts, we have the Lambda functions that perform the logic that the config rules rely on to evaluate whether or not a resource is compliant. SSM documents, which is kind of a wrapper around Lambda that performs remediations against the resources that are found to be non-compliant. And the event logging infrastructure, so that as those two scripts, or like those two resource processing bits emit determinations or produce logs or decisions, you want to be able to bring those back to whatever a logging and alerting infrastructure you have on-prem. Permissions that the master account needs are an invocation policy and SSM document permissions on those Lambda functions and SSM docs to allow the member accounts to use them, as well as access to logging infrastructure. In your member account, those will have the actual config rule resource definitions, which reference the Lambda functions in your master account, and they will be tied to a resource type scope. So if you have a config rule targeting S3 buckets, that will be the scope of your rule. And then remediation actions, which are tied to those config rules and to the SSM document in your master account. Some permissions as well in there for the config service to describe resources and then trigger the remediations to trust the config and SSM services. So those are the building blocks. How do they work together? First off, we'll go around the example of saying our policy is EC2 instances should not have an EIP or a public IP associated with them. Let's say we want to encourage adoption of load balancers as the public-facing tier of our environment. So when somebody creates an EC2 instance, the config service will be notified, and it will create the CI. If we have a config rule that has EC2 instances in the resource scope, it will start evaluation of that config rule. So what does that mean? Config will invoke the config rule will invoke the Lambda function in the master account and will pass across the configuration item, that JSON representation of the resource, to the Lambda function as part of that payload. Ideally, your Lambda function will be able to determine whether or not the resource is compliant just by the contents of that CI. However, often we found that we end up wanting to describe other resources that may be contextually useful when trying to say if that thing's compliant or not. We even have some functions that are doing port scans or pulling HTTP response codes off of resources so that we can get an idea of what effective access is instead of just trying to determine if something is compliant based on that one possibly narrowly scoped CI. So after the config rule, that Lambda function completes, it's expected to provide back to the member account's config service a compliant or non-compliant evaluation. That evaluation itself is a config resource. It's called a config resource compliance object, along with its own CI. When that CI is delivered, it is then represented in the config service just like any other S3 bucket, EC2 instance, whatever. It's there, it's queryable, it's exportable, you can do anything you want with it. If you want to go down the path of remediation, you'll have that SSM document that lives in the master account, which is linked to that config rule. Config, upon receiving a non-compliant evaluation, will trigger that SSM document, provide over the resource ID that it needs to respond to, and from there, it's up to whatever you want to do. Your remediation could be super granular. You might just go in, try to go in there and modify resource-based policies in the IAM policy itself. You might want to be just use the nuclear option and delete the object entirely. It really depends on how much code complexity you're willing to take on and how much risk your organization's willing to tolerate when it comes to removing these non-compliant resources. So after the remediation modifies that underlying resource, that's again going to trigger a CI update. So that will start the process over again, where that config rule will trigger, it'll reevaluate, and ideally, it'll come out the far side of the second evaluation as compliant. If it doesn't, that means that your remediation, your config rule aren't speaking the same language, and you'll end up just kind of looping through the remediation and config reassessment process over and over and over. That's a good thing to monitor for. It means that your remediation, the remediation is not directly addressing the risk represented by your config rule Lambda function. I have SNS logger, CloudWatch logs. As these things are happening, you want to have some way to get events emitted from the config rule and the remediation into your Slack or PagerDuty or Splunk or something to make sure that your operations team can keep track of what's going on, of what resources your auto remediation program is involved with. So that was kind of a whirlwind tour, but I'm going to hand over to Adam, who will talk about some of the steps that we used in adopting and deploying this kind of process across our organization.
Thank you, Scott. Thank you. So remediation readiness. This is our process to achieve our end state, which is where we try to get the teams to become fully compliant, and at that point, the infrastructure is all being remediated via automatic remediation. This consists of 3 different stages. We start with our audit stage, where we deploy the config rules, and the config rules run and scan the resources and identify any resources that are not in compliant with our policy. Next, we have the compliance phase. This compliance phase is where we give the teams time to go and remediate and fix all the findings that the config rules have identified. The amount of time is based on the severity of the findings, so whether it's a critical, a major, a minor, et cetera. And this stage is really important to give the teams time to fix this stuff, because once you trigger the auto remediation, if they haven't fixed it, it will almost certainly cause an outage. So after they've gone through and fixed everything, and they're now at 100% compliance, we move to the auto remediation enforcement phase. At this phase, when we detect that the teams have achieved 100% compliance, we require them to enable auto remediation enforcement. And at this point, all future resources that are created that are in violation will trigger an auto remediation, and they will be fixed forcefully. But if you're trying to deploy something that is multi-account, you have the master and the different other satellite accounts, you probably are going to have teams and customers that are going to need unique use cases that are going to be outside the bounds of your normal corporate policy, and this is where exceptions come in. So there's two different ways that you can apply exceptions for auto remediation in AWS. Config provides an AWS native method. It's just called the remediation exceptions. And this is a slightly overloaded term because it can mean exception via exception from the auto remediation or an exception that's been triggered because of, for instance, like an error in your code execution. So if auto remediation runs 5 times, then and it doesn't succeed, AWS will put a remediation exception to stop it from continuing to run and incurring billing and creating an endless loop. It's great that you don't have to build that component of the exception process. However, there are some drawbacks. There isn't a GUI, so you're still going to have to build some kind of code to extract that information and present it in a way that makes sense. And the bigger issue that we found is that in config, if there is a non-compliant resource and there is an exception, it doesn't tell you that there's an exception. So you actually have to pull out the entire list of non-compliant resources, the list of exceptions, and then do a diff between them to find out which ones are actually non-compliant resources. So we went the route of having an external tracking system where it did take more work because we had to build a database, a backend, some way to track all this stuff. But we are able to do things like if there's an exception that is valid, then that means that resource is actually compliant with our policy because they have some kind of other mitigating controls or some kind of approvals to make sure that they are in compliance with corporate policy. There are a few considerations when it comes to how you're building this. Renewals is something that we believe should not be, is required every year. We don't believe in the idea of allowing an exception to persist forever because eventually, at some point in time, they're going to remove that resource. And that exception is no longer going to be necessary, and you're going to have an unnecessary exception, unnecessarily exposing resources to the internet. Submissions are also really important to track what type of information do we need to properly gauge and accept the risk that the exception is going to incur. So, for instance, are there any additional mitigating controls to prevent an unintended exposure? Is there sensitive data in the account? And tracking what is going on with the process of the exception is also going to be really important. Inherent in this is having an approval process as well so that the right people are approving this exception, and that tracking will help you track to make sure that the approvals are getting done in time, and when the exceptions do expire, that we are taking the right steps to make sure that we're getting them renewed or removed. But if you have auto remediation, it's almost inevitable you're going to run into a scenario where something's going wrong. So how do you deal with that scenario? If something goes wrong, what do you do? The first step is awareness. We want to make sure that your management team is very aware that it's possible that you're going to experience an outage if an auto remediation triggers. The other team that needs to be aware is the development team that's going to be impacted by this. They need to understand what it means, what these auto remediations mean. You don't want to have a team go off and build an EBS volume that ends up getting terminated or deleted, and that was their only copy of all the software on there. So you need to think about that and making sure everybody's aware. So resilience is also very important in this, and making sure that teams understand that their data needs to be resilient. And the customized exception process that we built comes in really handy with this self-service shutdown concept that we have. We have an ability to give the teams a break glass feature that they can put an exception on their resources to stop our auto remediation in case it does cause an unintended outage. And then that gives us time to go in and dig in, figure out what's going on, why is it causing this if it's not intended, and then go about fixing it. And of course, the last one is having your operations center spun up on this. Whether it's a SOC, a GOC, a NOC, whatever it is, they need to be people who are savvy in the cloud, or at least understand the basic concepts of the cloud. and they need to be aware of the playbooks and how to deal with auto remediation issues. Now, when it comes to remediations, we have 3 general types. We have modify in place. For instance, if you have a S3 bucket that doesn't have public access block, you can just add that flag, and now the resource is compliant. The other is deleting the resource. For instance, NLBs, it's easier to delete the listener than to try to figure out which instances, which security group rules are causing violation. So we just delete the listener, but it's important to capture the configuration of the listener to send it to yourself, your operations center, and the teams that are being impacted so they can go back and recreate the resource and identify the resource if necessary. And clone and modify is the last one, but it's the most complicated. For instance, if you have a security group that is in violation, instead of deleting the security group, which may impact other instances that are attached to that security group, we create a copy of the security group, delete the violating rule, and then reattach that new security group to the instance that triggered the violation. That way we minimize the scope of the auto remediation. And notifications, as Scott talked about earlier, this is really important to give us visibility into what's going on with our environment. We track things like when evaluations are starting, violations, remediations, and the 2 sources are the lambdas, which are doing the evaluations and the audits, and the SSM documents that trigger the auto remediation. And we have a very, I'd say, pretty normal, typical message flow path where it's feeding to SNS and the SQS to retain it, and then we use ECS to pull the images off or pull the messages off, process it, and then we push it into Splunk, email, and Slack, depending on what type of metadata is associated with the notification.
I should mention that piping those remediation messages to Slack is a good way to stay awake through the whole day, because you never know which one of those is going to be the remediation action that causes a global outage or something. At this point, we've deployed 15 or 20 config rules with associated remediation actions. It still seems like with every rule, we're learning more things. We're running into more obstacles and figure out creative ways to get around them. One pattern that we've used in pretty much every rule is to parameterize them. Config rules can be provided a parameter on an account-by-account basis, or actually region-by-region basis, that can be taken into consideration as the rule is evaluating. So if you need the config rule to act differently in production versus non-production accounts, or if you want that external database of exceptions to be applied as parameters on the config rules, that's a good way to do it to reduce the amount of code duplication that you have to write. Instead of writing multiple rules to address varieties of a single scenario, write a single rule that can use parameters to change the way that evaluation is performed. The AWS docs on remediation configurations has something along the lines of, you can use these to trigger a remediation such as something like SSM documents. In reality, it's the forward model T option. You can have any color as long as it's black. You can have any remediation trigger as long as it's SSM, at least today. There are some limitations there. With CloudFormation, there's no support for SSM update operations, and there's no organizational sharing. You cannot delete or update an SSM document content without unsharing. So if you need to update the remediation document, you are unsharing it, deleting it, creating a new one with the new content, resharing it. It's a little bit of an ordeal to do. If you're willing to do a different route rather than using the built-in auto remediation triggers, you could instead use event bridge rules to trigger a Lambda function in the master account instead of going the SSM route. That might give you a little bit more flexibility, but it would mean writing a little bit more code, managing some more rules on your own. As Adam mentioned, the remediation action is important. You need to really thoroughly consider what side impact your remediation actions could have. One that we ran into not too long ago is we're doing the modify and replace approach for some of our EC2 group rules. Well, it turned out that another instance was trusting, let's say instance A was in violation, instance B was trusting instance A by security group reference. By detaching the security group on instance A, it lost the ability to communicate to instance B. So rather than just impacting its external accessibility, we also basically quarantine that instance from the internal network. So as you're writing out these remediations, consider what side effects that modification might have. There are times when your remediation action is triggered that it is useful to have information from the config rule when it's deciding what it needs to do. For example, if you have a config rule targeting load balancers, and only one of the three listeners on a load balancer is non-compliant, the remediation doesn't have any way natively of knowing which of those listeners needs to be remediated. So there's a couple of ways you can pass that info across. You could create an external record using something like DynamoDB to say, hey, for this resource, when you do remediation, this is the listener that needs to be responded to. You could put a tag on the offending resource. I'd recommend protecting that tag key by an SCP to pass that information across to the remediation document. So when it gets the resource ID, it describes the resource, pulls the tag value off, and then it has the context it needs to do the remediation. Or an interesting approach, which was we were introduced by Amal Al-Khatani of the AWS ProServe team, is to hijack a free-form field, part of the evaluation called the annotation, with that context, with that data, and then parse it out in the remediation action. That makes it so you don't have to tag something, you don't have to create another record. It's all kind of part of the same resource evaluation item. Most of the flows that we've gone through have been triggering config rules based on CI change. You can also set up a config rule to trigger on a periodic basis. However, when they trigger, config will pass different payloads to that invocation. If it's triggered by a configuration item change, you get the configuration item. However, if it's triggered on a periodic change, you'll only get account level information. So it would fall to you, or it would fall to the config rule to collect those CIs, perform the evaluation across the CIs, and then make a determination for each of them. As a result, it's very uncommon to see Lambda functions or to see config rules that are triggered on both periodic as well as on change intervals, because they're really two different flows that you need to address. Even the AWS managed rules, which make it so you don't have to write your own Lambda functions, I don't think I've seen any examples where a single rule is being triggered both on a periodic and an on-change basis. So yeah, exercise caution before deciding to write a rule like that. I think we're at time, but here's a handful of other things that we've encountered over the last 18 months of developing config rules. The rock'em sock'em bit, your Lambda functions inevitably will run into conflicts with other automation. Config rules will usually win. Like they're typically event-driven, they're very fast, they're written in Lambda. They're probably gonna win over somebody that's intermittently doing a Terraform state apply. So if you do end up doing something like this, monitor for repeated remediation actions targeting the same resource ID, because there's a good chance that you've got robots fighting robots. I won't cover the rest of these so we can save some time for Q&A, but thanks for your time. Please fill out the session survey. It's useful for us, useful for conference organizers. Thanks, everyone.
Questions? All right. Let me give you the thing.
What does the testing look like for your remediation? And you don't want to break prod like you mentioned. So I'd be curious how you guys had that set up.
Yeah, testing remediation. So we have a stage organization set up, stage member, stage master. We pull together as many use cases of the resource that we're doing assessments of and recreate that in our test environment. Also, we don't deploy the config rule and the remediation in remediation mode at the same time. We always deploy it in an audit mode, get back the list of non-compliant resources, understand why those things were being considered non-compliant, and if it's what we would have expected. And often we end up going through a couple iterations of the config rule before we get to actually releasing the remediation.
So I think one theme from the questions in Slack is how you build that trust with the operations team.
Oh boy.
It seems like you've highlighted a couple strategies there. Start in audit mode.
Yeah.
Test aggressively.
Yeah. Ideally, like Adam said, you don't enable remediation in an account where you know it's going to trigger immediately. You get the rules out in an audit mode so that you know which resources are non-compliant.
How long do you give them to go through that stuff?
It depends on the rule. If it's something that presents an immediate risk, between 24 hours and 30 days. If it's something that's a little bit lower, not really best practice, but it's unlikely to result in us getting owned immediately, 2 months. And then we typically set a time frame that after an account is compliant, they need to enforce or allow us to enforce the policies, enable remediation mode in their policies. within another 30 or 60 days.
Like, what sort of visibility are you giving the team into the stuff? So they can see their own config? Like, is
Yeah.
there an upward visibility? Like, what's the other?
Yes. Since config is running in their own AWS accounts, any account owner can go into the config service, see the rules that we've created, and see the evaluations that are getting spit out, so they can see what their non-compliant resources are at any point in time. We also do upward reporting. That's less commonly on a resource-by-resource basis. It's more common that, like, hey, here's this VP, here's the number of accounts that they have that are compliant or non-compliant, and we can use that cycling through our security program managers to accelerate compliance against those rules.
Cool. Did you find that the term auto remediation freaked people out to begin with?
Yes. Yes.
Okay.
Yeah.
We have a suggestion from Kat that correct for drift might
Correct
be a
for
better,
drift.
more fast and furious. inspired.
Yeah. That might make less hairs prickle on necks when
I think my
when people
program
hear them.
manager is listening right now, so maybe consider that.
Excellent. Well, give it a shot. Report back. And then obviously the last one I always have to ask when I see amazing tooling is, so when are you open sourcing?
So we were going to try and open source at least a couple of the rules today. We didn't get there.
Okay.
We're hoping to be able to get on a reInvent stage later this year. If that happens, we're going to try and get at least some of the scaffolding of the remediation pipeline in a rule or two released as part of that.
I mean, we're cooler than reInvent.
You
but
are. Yeah.
I'll allow
If we
it.
don't get it by then, we'll get it more on stage next year here.
I don't want to wait that long. Just drop it.
Yeah.
All right. Well, thank you very much.